Lesson 2-2, solving one-step equations. Our essential question is how do you solve a one-step equation? Our new vocabulary is inverse operations. What inverse operations are? Inverse operations are operations that reverse each other. They reverse each other. You've worked with these before, probably in elementary school. They called them fact families. So inverse operations are operations like addition and subtraction, or multiplication and division. So again, they are operations that reverse each other. And we're going to use those to solve equations. So addition and subtraction, multiplication and division. Those are the inverse operations that we're going to be working with throughout this entire chapter. One-step equations. We are going to show you a method to use, actually a couple different methods that you can use for showing your work for solving equations. When you show your work, it's best to keep it organized just so that your teacher can figure out if you've made a mistake somewhere. Some of you may like to solve your equations with what we call train tracks. And if you solve them this way, you're solving them up and down. So, we have an unknown number x, and when 7 is added to it, we know it equals 10. In your head, I'm sure that you can solve this because you've seen these in elementary school. In elementary school, they looked like this. They gave you an open box like this, and they said, what number would have to go in the box so that it was true? And in elementary school, you would say, oh, it's 3, because I know 3 plus 7 is 10. Well, our equations are going to get harder and harder and harder now that we're in algebra. So we need a method, not just guessing and checking, and not always using mental math. I don't mind if you use mental math on easier problems. I just need you to have a method in place for when the problems get trickier. So, the method that we're going to use with the train tracks, one of the ways to show work, is to ask yourself, if I want the x to be all alone on the left-hand side of my equation, what can I do to get rid of the addition adding 7? The answer would be to subtract 7, because that's the inverse of adding 7. If I subtract 7 from my positive 7, they're gone. They've canceled out. If I subtract 7 from my 10, I get 3. So my answer is x equals 3. Now, if you wanted to go back and check, you could go to your original problem. The original problem looked like this. And you could plug in your answer where the x is to check and make sure that you are correct. 10 does equal 10. Remember that an equation is like a balanced scale. It's like a balanced scale. So the balance is your equal sign, and whatever stuff you've got on each side has to be equal in value. So whatever you do on one side of an equation, you have to do the same thing on the other side, or else you're going to affect the balance. It's not going to be an equation anymore with an equal sign. So whatever you do on one side, you have to do on the other. Now, the next one, the second example, you may notice that the variable has moved, so the variable is on the right-hand side. It doesn't matter what side the variable is on. Not at all. Okay, look at where my equal sign is. Now, a different method that you might use, you might like to write a cross. So you might like to subtract the 8 on both sides, like this. And then you would get 20 minus 8 is 12 equals x. That's another way that you could show your work. A third way going across, I'm just going to leave a little bit of extra space on this one. Maybe you want extra space. Here's the equal sign. X plus 11, I'm going to subtract away that 11 on both sides. So now I get x equals. And on the right-hand side, when you're working with negative signs, sometimes it is helpful to write it across instead of up and down. Negative 5 minus 11 is the same as -5 plus -11, which is -16. So with integer operations, sometimes it could be helpful to write it across. So any of these ways of showing your work would be acceptable. And remember, the importance of showing your work might not be evident when we do one-step equations, but later on it will be. Now, subtraction equations. So all three of the first ones were addition equations. Now we've got some subtraction equations. Now I'm going to go back to that first method because I'm an up and down kind of solving person. Put a line through my train tracks. So, x minus 9, the inverse of subtracting 9 is adding 9. So, x equals 13. The next one, I would have to add the 10, the inverse of subtracting 10. The 10s cancel out. X equals 17. And then the bottom one, add 3. The 3's cancel out, and x equals. Remember, when you add a negative and a positive, the result could be either sign. I have more of the negative. How much more? 5 more. So the difference between 8 and 3 is 5, but I had more of the negative number. So my answer is a negative. All right, moving on. Solving multiplication equations. The inverse of multiplying is dividing. So on all of these problems, we will be dividing. Remember, your integer operations, your signs, when you are multiplying and dividing, if they have the same sign, the result is going to be positive, but if they have different signs, the result is negative. So I divide by 3 because the 3 right next to the x means multiplication. So the inverse of multiplication is division. 12 divided by 3 is 4. The next one I divide by the -5 because I want the x all alone. A negative divided by a negative is a positive, so my answer is +5. The last one, I divide by 4. A negative divided by a positive is a negative. 28 divided by 4 is 7. You can probably guess the last type of equations are the division equations. These are a little bit trickier because they look like fractions at the beginning. So we do tend to have some students forget what that means. So with these division equations, the inverse of dividing is multiplying. So if I multiply by 3, it's going to cancel out dividing by 3. So my answer on this first problem is x equals -18. Think about it if you check this. In the original problem right here, if I put in -18 where the x is, this should make sense to you. -18 thirds, or -18 divided by 3 equals -6. The next one, I'm going to multiply by -5 on both sides to get the x by itself. So, x equals -50. And on the third example, multiply by the 7 on both sides. So x equals -14. Now the fraction equations, these are a little bit trickier. To eliminate a fraction that's multiplied by your variable, we use the reciprocal. Because remember that reciprocals are multiplicative inverses. So reciprocals, like the reciprocal of 3/5 is 5/3. And what happens when you multiply reciprocals together you get the same number in the numerator and the denominator, which would just equal the number 1. So, on this first one, I'm going to multiply by the reciprocal of 2/3, which is 3/2. So multiply by 3/2 on both sides. So 3 times 2 is 6 and 2 times 3 is 6. So these fractions cancel each other out. I'm going to put a 1 under my -6 and then multiply straight across. I get -18 divided by 2, which is -9. And then on the second one, the reciprocal of -3/4 would be -4/3. So multiply by -4/3. Put a 1 under my -2. All of these are gone on the left-hand side. Multiply straight across. Notice that I put the negative sign on the top of the fraction for my reciprocal. That's just easier for me to work with. A negative fraction could have a negative on the top or the bottom. Means the same thing. So if I multiply straight across, I get 8/3. 8/3 is the same as 2 and 2/3 because 3 goes into 8 twice with 2 left over. You're ready to write your summary now to solve a one-step equation. Please finish it, complete sentences, and here is your homework assignment.